Yeah, thank you. Thank you, Jess, for introducing me. I would like to also introduce our panelists today, those who will be giving you information regarding the topics of Struck By for the excavator and crane activities. So let me start off by saying Dr. Robert Harrison is the Public Health and Medical Officer with the California Department of Public Health Occupational Health Branch and Clinical Professor at the University of California, San Francisco in the Division of Occupational and Environmental Medicine. He served as a technical and scientific consultant to federal OSHA and CDC and NIOSH, and was a member of the California Occupational Safety and Health Standard Board. Hank Cierpich is a retired safety engineer and workplace fatality investigator. He has worked extensively with the California Department of Public Health as their fatality investigator under the FACE program, which stands for Fatality Assessment and Control Evaluations. Mr. Cierpich has an extensive career with the Los Angeles Department of Water and Power as their corporate safety engineer. Mike Walsh is the president of the Dearborn Companies, a civil and structural firm specializing in heavy lift, rigging, and construction engineering. Mike is a full voting member of the ASME P30 committee, and he also serves on the board of directors and the technical committee for the North American Matting Association. Mike also is an active member of the Association of Crane and Rigging Professionals. Tom Gordon is a 32-year member of the I.U.O.E. and has been a training director for the I.U.O.E. Local 1414B for 7 years. Tom is currently on multiple committees, both local and national, involving safety standards, testing, and best practice protocols in the construction industry, specializing in crane and rigging safety. Derek Sather is a graduate of the DOL Registered Apprenticeship and Operational Engineers since 1997, with a career specializing primarily in crane and rigging operations. Mr. Sather ultimately elevated to Master Instructor for the I.U.O.E. Derek is currently the Director of Safety and Risk Management for Sims Crane and Equipment Company. So I will turn it over to Dr. Bob to start us off on the excavator topic.
Thank you so much, and I want to thank Alanna and Jessica particularly for all the hard work you've done in putting together this great panel. I want to thank my colleagues at the National Institute for Occupational Safety and Health in their Division of Safety Research, which is in Morgantown, West Virginia, Nancy Romano and staff there. We're supported by CDC NIOSH for the last 25 years. And Laura Stiles, who is the program manager for the California FACE program. Alanna, you introduced me as Dr. Bob, and I feel a little bit of a fish out of water because I'm a physician in occupational medicine, but I've been interested in workplace fatalities as what I would call a teachable moment. So the California FACE program, which is funded by NIOSH, tracks and investigates workplace traumatic fatalities in California. We have about between 350 and 400 fatalities per year. So that's about one per week on average. And they are all sorts of preventable traumatic fatalities. We obviously can't investigate all of them. We do anywhere between 5 and 10 per year. And we select ones that we think provide some sort of teaching moment that can be used for outreach and education that can illustrate risk factors and preventable causes of workplace deaths. As we track these, we really look at whether or not there's something in a pattern or new or has emerged, really something that might be old, but nobody really has thought about or paid as much attention to as they should. If you're looking for the investigations that I'm going to talk about with Hank, You can look up the California FACE program, and we have a website. We have over 275 of these investigations that are posted, including the 2 reports of the cases that I'm going to present to you. They really make, I think, really good discussion and teaching tools. So we really encourage anybody who's doing safety and health training in construction to check out our website and use these investigations. We also have a lot of other fatalities and a series of really impactful videos. Next slide. So in June of 2020, we got reports of 2 fatalities that occurred on construction sites connected with buckets that disconnected from automatic or quick couplers. And I think what really struck us is that there were these 2 fatalities that occurred really within almost a week of each other, seemingly by the same mechanism. And this was really the first time, I think, in 25 years of tracking workplace fatalities, we had seen 2 that occur within such a short time period of each other. So we investigated these. Next slide. The first thing that we do is we go back and see, well, are we going over the same terrain, pardon the pun? Have there been other fatalities in connection with quick couplers? I go onto the federal OSHA fatality catastrophe website and do a search by keyword. And sure enough, you can see that there were several other fatalities, including one that goes all the way back to 2007 in California. Our team, believe it or not, Laura, Hank, and I were, on the job back in 2007. I can't remember this fatality that occurred in 2007, but there was one, and you can see that there were several others, including one recent one in Wisconsin. Next slide. There was also, by the way, here's the Wisconsin case. This was a Mine Safety and Health Administration investigation. So I also look at incident reports there. Next slide. So I'm going to describe the case, show you a few pictures, and I'm going to ask Hank to comment because Hank performed the investigation and was on the scene. So this was a construction heavy equipment operator. He was a trainee, so he was relatively new on the job, and he was struck by a bucket that came loose from a quick coupling device attached to the end of a boom. He had unloaded 2 loads of dirt from a trench, and then he swung the boom of the excavator over to the side. He got out of the cab while the boom was elevated. And as he was walking towards the boom, the bucket detached from the quick coupler and fell to the ground, striking him. And immediately, within a few minutes, causing his death. Next slide. Now, quick couplers, for those of you who may not be familiar, are typically aftermarket devices that are manufactured by various companies, and they're installed at the outer end of a boom on construction and earth moving equipment. And they're basically designed to get working tools or buckets on and off the end of a boom rapidly without the operator getting out of the cab or performing any manual operations. Next slide. They are mounted on the end of the boom by pins that would otherwise be the mounting for the bucket or attachment. And they pick up and release the bucket the operator picks up the bucket, depending on the design of a coupler, typically with a pad inside the operator's, within reach of the operator. There are a lot of different variations in the design of quick couplers. And there are probably, I would say, hundreds of thousands of these operating on the market today. Next slide. Here's an example at the end of a quick coupler. Next slide. Here's a good schematic. You can see they're typically using hydraulic mechanisms to lock and unlock the pins that attach to the bucket. Next slide. So let's move to this first incident construction site. Here's the picture of the machine. You can see a very large bucket attached to the end with a quick coupler between the boom and the bucket, the operator in the cab. Next slide. Here's the size of that bucket, and you can see when that detached and struck the operator that there's little chance of survival given the weight of this. Next slide. And here's a picture of the actual quick coupler device attached to the bucket down below. Next slide. And the keypad within the operator compartment. Next slide. Let's go back a slide. So, Hank?
Yes, sir.
Are you on the phone? Okay. Hank, do you want to add to the incident scene here? You were out there, and I want you to add some comments.
As you can see, the control panel that's up on the screen right now is the only device that controlled the fully automatic type of quick coupler. When they first came out with these quick couplers, they did not have the automatic feature. You had to manually connect them as well. Then they came out with a semi-automatic device, which required the operator to get out of the cab and do the final connection with a safety pin to ensure that the bucket or attachment was secured. And today they have what they refer to as the full automatic connector, all controlled by panels similar to this one here in the cab. And the operator simply pushes a button. A hydraulic device locks it in place, and a light or a bell will indicate whether it is connected properly or not. If for some reason during operation the device, whether it be a bucket or some other attachment, comes loose or jarred, a warning should appear on this device as well. Usually it's in the sign of a blinking light or a bell or a ring of some sort. Everyone has their own different types of panels, but they're all similar in sense as far as operation goes.
Okay. Thanks, Hank. And this was, as I think you implied, this is an aftermarket device system, yes. Electrically operated with hydraulic controls.
Exactly.
Okay, next slide. So case number 2 was a laborer, and he was working in a trench, and he was struck by an excavation bucket that also came loose from a quick coupler. The operator of the excavator was curling the bucket into the boom when the bucket came loose, hit the ground, and bounced into the trench where the victim was working. Next slide. Again, another schematic showing you the excavator, the boom, the bucket. Next slide. And here's a picture of the excavator with the boom and the bucket attached. Next slide. Again, a very large bucket. You can see the quick coupler between the boom and the excavator on top of that bucket. Next slide. And now you see pictures of the incident scene. Next slide. I think we get a better view. So you can see the excavator was on top of this trench, and as the boom with the bucket was swinging over the trench, that bucket detached, and the victim was working in the bottom of this trench, and the bucket came crashing down on top of him. And what you're seeing in this photo is the rescue getting the chain attached to that bucket and removing it from the trench. Next slide. This is the inside of the cab. You can see another keypad device that's used to attach and detach that bucket. Next slide. Let's go back. Hank, you want to comment on this case?
Well, yeah, as you can see, this particular device is on a cat crawler type excavator, and so everyone has their own different design, if you will, but the operation is very similar. That keypad, even though I wasn't able to get a better picture of it, is a push button type of device similar to the other one, whereas the operator, all he has to do is literally push a button to activate the controls of the quick coupler.
Okay, next slide. So let's finish. So what went wrong here in these cases? What's the underlying or root cause? What's the prevention? what can we do to prevent these and educate operators and workers on these sites? So first of all, I think in the first case, it's apparent, hopefully to all the listeners, that operators should always lower the bucket to the ground before exiting the cab. And in the first case, it was unwitnessed. There was another manager, supervisor, but the reason why that operator got out of the cab with the boom elevated is really still unknown to this day. He should have lowered the bucket to the ground before he got out of the cab. If there was something that was wrong with the attachment of that quick coupler, he lowers it to the ground and looks at it, does not get under the quick coupler and that boom to take a look. There may have been a malfunction, but he could have inspected it by lowering it to the ground. As a corollary, workers should never walk beneath that excavator boom swing radius or an elevated load. So don't get under there. And we recommend that employers should follow the manufacturer's recommendations, train workers how to make these visual inspections, perform regular maintenance, and have methods to test connections. In both of these cases, we suspected, well, was there a malfunction of the electrical or hydraulic system? Hank, you want to comment? I believe, correct me if I'm wrong, that the testing of the hydraulics did not reveal a defect.
Exactly. After the incident occurred, they did run the piece of equipment through a testing period, if you will, and they found no mechanical failure with the system, which is surprising because the industry, as I've done research on these particular type of fatalities, they refer to them as unfortunate disconnects, if you will. Basically, they're unexplained, and I kept thinking about, this is a mechanical device. You can definitely explain what happened or figure it out, but it's just happened all too often. And lo and behold, last year in August, we had a third incident here in California. I'm still in the process of investigating that particular incident, but I was able to gather some information. I apologize for not having slides on this one, but it was similar to this last two, where a construction company was installing a utility line on the side of a street. The operator of the excavator swung the boom over to the side and automatically disconnected the bucket in order to use the boom as a lifting device to lower a new piece of pipe into the trench that he had just dug. Inside the trench were two pipe fitters, if you will, that guided the pipe into place and then sealed it to the pipes that were already there. After the pipe was lowered and disconnected, the boom operator then swung the boom over to the side where the bucket was and reconnected it. He then swung the boom back over the trench and was going to continue digging, but just as he started, the bucket disconnected and fell into the trench, hitting and striking one of the workers and killing him. Again, very similar to the last two in the sense.
Yeah.
So I'm going to be doing more investigation in this one because I have two theories that I'm really concerned about, and one of them actually is operator error, which unfortunately, unless you actually witness it, you can't really verify something to that effect, especially when everything else works properly. How did that disconnect? The second one is the possibility that the mechanism themselves might have a flaw in them. And what I'm referring to is that the hydraulic pressure that's used to hold the safety pin in place may not be sufficient enough to withstand the loads that are applied to that bucket while in operation. And if that's the case, then there has to be a recall or some redesigning of the system. The problem I've had up to this point is finding a company or a business that's willing to do the testing to find out. There's a liability issue here naturally, so I haven't been able to find anyone to actually run some tests to see if this is a true theory or not. but it just would make, it makes sense to me that that might be one of the issues that we're dealing with. And the other part of that is operators don't recognize or fail to recognize that during operation, when a bucket becomes dislodged because of the pressures applied to it, they should immediately stop working and, you know, make the corrections necessary. My thoughts are some of these operators are not skilled enough to have that knowledge to fully understand or recognize this particular problem, if you will. In this third case, the operator was fairly new on the job. I don't know exactly how long, but I know he was fairly new to operations. So as you can see, there's still a lot of work to be done in this category, and I'm anxious to finish this third investigation, knowing that, you know, some of the recommendations might be similar to the last two, but I'm curious to find out if I can uncover anything new.
Thank you, Hank.
And I pray that none of these happen again, but there is a definite issue here that needs to be corrected.
Thanks so much, Hank. I think I had just one more slide. I'll just go quickly. We also had some recommendations on manufacturer-approved compatible attachments as the issue Hank mentioned about engineering and design of these devices, and the retrofitting issue. But I'm sensitive to the fact we have a lot of other great presentations, so I'll end there. So I want to thank you, everybody. And there was one comment in the chat, yeah, trench box. Yeah, there wasn't a trench box, Aaron, and we had a lot of discussion about whether we would make other recommendations about excavating and trenching. Yeah, there's a lot of issues here.
There were other violations, you're absolutely right, but they weren't directly related to the incident. That's why we never brought them up.
Yeah, so thank you, everybody.
All right, well, thank you so much for your thoughts on that. We're gonna head over to lift planning for safety, and Mike is gonna kick us off. Tom will come next, and then Derek will wrap us up.
Great, thanks, Alanna. I'd like to echo Dr. Bob's expression of appreciation to Alanna and Jessica, and also I'd like to thank the co-presenters here today for everybody's time, and especially all of you that have tuned into this, and for your time and for your kind attention. So my portion is to briefly and kind of the 50,000-foot view of lift planning for safety, and as it does impact, no pun intended, struck by. Slide, please. So one thing I would like to do is I'd like to try and broaden our scope, broaden the view here, that we talk about lift planning, and honestly, it's really, we're dealing far more with load movement or load handling. It's not just simple lifts. And when you think about what's commonly thought of when you're doing lift planning, it'd be a mobile crane, tower crane, derrick. Click, please. But we also get into a variety of other, we also get into a wide variety of other lifting devices now, lift handling equipment. And this spans anything from now gantries, tuggers, jack and slide, where obviously you've got line of fire issues there. The use of SPMT, self-propelled modular transports, and heavy haul for load movement, load transport within a project, not just between projects. And even down to something simple as craft rigging, or in some places referred to as bull rigging, where we're using hoists, chain falls. And again, we're looking at load movement, and it's not just in a vertical move, but it's also the horizontal elements that come into this, and all combined, we have safety factors that need to be considered and addressed. Click, please. As we saw with the tragic results with Hank and Dr. Bob's presentation, you know, excavators are being used now as lift handling equipment, telehandlers, forklifts, all of those are involved. And even if you take a look and consider a concrete pump, while it's not necessarily lifting, it is placing material. You have a boom that's involved. So you've got overhead considerations in terms of overhead power clashes or structural clashes, boom clashes between pieces of equipment, and environmental considerations from ground conditions, ground stability, or if you're working on any kind of an elevated deck. All of these need to be evaluated and need to be planned as part of the load movement activity. Click, please. So when do we plan? Standard move, critical or engineered pick? Does every move need a plan? Candidly, yes, absolutely. It needs planning. Does it require a 200-page lift plan with full-blown engineering calcs? Absolutely not. But it does require every single one of these moves to try and mitigate some of what we saw, even with the struck bys in Bob and Hank's presentation. That it's planning. It's looking at the potential hazards, line of fire, making sure that you're out from under a suspended load and the like. Click, please. So to mitigate risk, right? We're looking to pre-plan. So we want to actively investigate and assess ahead of time, right? So this is get out ahead of what the work activities are, and also not just regardless of how in depth the planning happens to be ahead of time and how well engineered and documented. Get out in front immediately prior to starting the work. Look for changes in the environment. Look to inspect the equipment and load handling devices that are going to be used and the loads themselves, and make sure that you don't have anything that is materially changed from your plans. The next, also communicate, and this is before, during, and after postmortems on these, after action reports. Not just to look at what went wrong, but what went right and how to be able to propagate that down the road. And then also, last but not least, actually do what you say you're going to do. Execute. So follow the plan and execute with that. Click, please. And at this point, I'm going to hand it over to Tom. We're going to go from the pre-planning to the actual doing. And Tom will take us through the world of tower crane, safe tower crane erection and disassembly. Tom?
Hi, I'm Mike. Thanks a lot. I appreciate the intro and appreciate your presentation. Want to thank Alanna, Jessica, and the other presenters for making this a success. I was part of it last year and it was a success, and happy to be part of it today. This list for tower crane erection is not the end all be all. This is not the list for every crane, every job site, and every situation. This is kind of a best practices list that we're going to go through. Same thing for the operation and the dismantling. Every crane that gets put up, depending on where it is going to have its own set of circumstances that are going to have to be dealt with. So, like I said, these are kind of best practices, and anything that you have specifically for a job you're looking at, this list can always be added to or taken away from. The first thing, and probably the most important, Mike was talking about planning before, is the pre-erection meeting. Discussing what's going to go on that day, making sure everybody's aware of their responsibilities and the hazards involved with their responsibilities. This is also the time when the discussion of how to set up and where to set up the assist crane that'll be put in the tower crane up would go. There should be written procedures that were developed either by the manufacturer or a qualified person. Those written procedures should be on site and available to everybody before work starts. You have to ensure that the crane has been properly inspected prior to delivering it to the job site. Proper communication systems are put in place between the signalman, the operator of the assist crane, and once the crane deck and cab are put on and your hydraulics and electric are installed, the operator of the tower crane itself, so that there's constant communication between them. If you look at that bottom picture on the right, you have an operator sitting in the crane, an operator in the assist crane, and a signalman who's given direction on, what movements have to be made in order to attach that boom. And any one of the operators involved in the procedure could be the ones who are swinging or moving around. If you lose any of that communication, you should always stop until it's fixed. Any last minute job site changes, road access, things like that. Inspection of all the rigging, chain falls, spreader beams, come-alongs, any equipment that's going to be used during the day should be inspected prior to use. The day's weather, which is probably going to be gone over in the pre-erection meeting, but the day's weather plays an enormous part. Looking at some of those photos, I'm sure you can tell that if you had a lot of wind blowing that day, or rain or ice or snow or anything coming down, those would be very difficult operations to be taking part in. So the weather is a big thing. Any overhead power lines or underground utilities or vaults, you want the tower crane manual to be on site in case somebody needs to go to that to check certain specifications. Proper tooling for the tower mast bolts or pin connections. That could be air guns or electric impact guns for putting the bolts in, or it could be pin pullers or any type of specialized tool for putting the pins into the tower mast sections and putting them together. Permits or road closures that have to be arranged in order for the parts to come in. Members of the erection crew should have their proper certs and licenses checked. That'd be your crane operators, your riggers, and your signal persons. And if the crane is electrically powered, all the regulations that are for the local authority that need to be checked to make sure that your power cables are run safely. And then ensure that the base section meets the plumb tolerances that are specified by the manufacturer. It's kind of like hanging wallpaper. If your first piece is crooked, everything after that is going to be a mess too. Next slide, please. Operation. Before the crane will actually be put to work, there'll be a load test performed. That'll be performed as per the manufacturer's specifications, or if a local authority has their own rules or regulations that go that are put in place for that. Shift inspection should be performed by the competent person. Operational aids, safety devices, and the control mechanisms are only part of the shift inspection. OSHA's 1926-1412 gives you a whole list. Operator must not engage in any practice that diverts his attention. Cell phones, that's the major thing right now. I'm sure everybody realizes. Weather conditions should be constantly monitored. You could be the operator climbing up in a tower crane, and in the morning it's sunny out, and in the afternoon it could start snowing, and your descent out of that tower crane could be incredibly dangerous because of ice accumulation on the ladders or the decking. So constant monitoring of the weather is very important when you're on a tower crane. Constant communication, again, between the signal person and the operator. A pre-shift meeting should occur every day so that everybody knows what the day's operations are going to be and what their responsibilities are to them. Safety devices and operational aids should not be a substitute for good judgment and safe operation. Don't think to yourself, oh, don't worry, I got the anti-2 block up there. They'll shut me off. I don't have to look up. You know, there's a lot of these different limiting devices that stop swings and things like that. Don't ever be led into a false sense of security that an electronic device is better than you actually paying attention. Always obey an emergency stop signal, irrespective of who gives it to you. The operator has to always have the authority to stop and refuse any pick if it's a concern to safety. A qualified person should be able to determine that that safety is assured and that the pick can proceed. Tag lines must always be used to control the rotation of any load that might be dangerous. Next slide, please. Disassembly of the crane. A lot of times you'll hear people say, oh, disassembly, all you're doing is just do everything backwards. Do it in reverse. Unfortunately, it just doesn't work that easy. There's a lot of times where you'll be putting a building up, a tower crane may be up for 6 months, 8 months. The access roads and job site logistics could have changed. Ways that you brought material in before and brought crane parts in may not be available anymore. The structures that weren't present before the erection of the tower crane, including whatever structure you were putting up, they're going to create their own set of challenges to taking that crane down. The tail swing of the tower crane could affect the ability to jack the crane down to a serviceable height so that your assist crane can actually reach it. A lot of times the crane has to be locked off at a certain position and you can't swing 360 degrees anymore. One of the pictures on the left on the top shows the derrick. A lot of times a derrick, it will be needed to be erected on the roof in order to dismantle it. And that derrick presents its whole other issue of problems and safety protocols that have to be put in place just to erect the derrick and then take it down. All the work during a disassembly is done at extreme heights. So you have to be extra careful with everything. Pre-shift meetings should, again, always take place before the work begins. And during disassembly, the path of the crane components is never guaranteed. It's not like when you're swinging it in to put it together. When you knock a pin off, knock a pin out, disconnect the bolt, you may think you remember which way that piece is going to kick, but it doesn't always work that way. So you should really be prepared for a crane boom or any other piece to kick or twist anyway. And that's the reason that the next bullet point, taglines should be used whenever swinging of a load is hazardous. When you're not exactly positive as to where that load is going to go, you should always have some taglines attached. And again, always keep track of the weather. Same issues that you would have had during the erection and the operation of the crane, you could run into during disassembly. That's about all I have. I think Derek will be the next one up, and thank you.
Thanks for the intro, Tom, and thanks to CPWR for hosting, and thanks again to all the other presenters and all of you attending. I'm going to kind of piggyback on some of what the other presenters already talked about, but kind of key in on site control measures. And obviously this is going to have a lot to do with planning and just trying to get out in front of things to be able to foresee some of the problems that are going to come at you. Obviously, one of the most important things on a job site is the schedule. They're very tight. The schedules are tighter all the time. If you don't believe me, go watch a Amazon distribution center go up in today's world. It is quite amazing how quick they can put a project together. And so the best thing is to communicate. I know it's been mentioned, but the more that you communicate, the more that we are going to have people that are not in harm's way, and the more efficiently things will go, and actually you'll save time and end up saving money. I want to start number one with the assist crane. Obviously you can see the assist crane is snuggled right in on this job at this point, but as it shows up for the day of the assembly of the crane, or even if it's for the disassembly of the crane, it's going to have access into the site. When the salesman was out at the project meeting with the representative from the job, I'm sure it looked a lot different than the day when the crane shows up. So we want to make sure he has access into the site, because if you have the assist crane that comes with 5 to 10 counterweight trucks or accessory trucks with it, it can definitely have a problem getting into the site, which causes a lot of havoc out onto the public road. And everybody knows if you're going to disrupt traffic in the morning on everybody's way to work, people go crazy. So I've seen some really bad things happen just from getting the assist crane access to the site. Once our cranes are dispatched, whether it's the assist crane or the tower crane, just remember, on average, a tower crane can be anywhere from 10 to 15 to 20 truckloads of parts. One of the really important things to think about, it would be a staging lot. You can really control how much time is held up in travel for the components to get to the site, and you can make the job much more efficient and much safer, because you don't have to stage quite as many parts on the actual job site, and you can have parts that are nearby, and you can control the sequencing much better and make sure that it's very timely as the things come in. You go to the next slide. Here's another crane that's it's a different project, but I just wanted to talk for a brief moment about site access and then people that are from the public access. So if you're putting a crane together, there is a very large fall zone, potential hazard. And you can see that the site access on the adjacent building here, and when the people enter the site, they're going to be walking directly under the tower crane. This created quite a large problem for us on this facility because this was their only way in and out from this site. Another thing that we had an issue with on a project that I was on as a crane operator is we were at a VA hospital, and just to get the pieces into the assist crane, we had to definitely disrupt the traffic around the hospital, right? And those are very unforeseen problems to try and navigate a large tractor trailer through a parking lot or things of that nature. And then you have individuals that are going to go from their car to the door, right? And I love my veterans, I love them to death, but if you put some tape up or you put some barricades up, they're going to go from their car to that door no matter what it takes. So just remember that when you're out there, people will drive through MOT setup, or they'll climb through the tape or the barrier or whatever it may be. So some extra bodies involved with controlling traffic and doing the best you can will much minimize how much disruption that there is as you're putting these cranes together. Next slide, please. As the cranes are accessing the site, it's very critical, as you saw from my first slide, that it gets congested, right? You start putting 2 to 4 to 8 to 10, 12 trucks of parts into a facility or a construction site, and it's going to make a decent sized site very congested very quickly, right? And that's going to create a lot of potential hazards for pinch points or struck by, or however you want to categorize them. One critical thing that I always tell people is please have enough spotters. Those large trucks and that large equipment, there are so many blind spots. People just do not realize. I mean, you're looking at the truck and you think that guy can see all around it and do his thing. And some of them make it look like they can see through the objects because they're so good at what they do. But truly, at the end of the day, there are just a ton of blind spots. So please make sure that there are enough spotters, designated spotters, right? Because if you say you're my spotter and then they get hung up over there working to trip a piece or land something out of the way or whatever it may be, and those trucks are trying to get off the road so they can, stop creating that hazard and mess going on, then things start to fall apart. So please make sure that you have enough spotters and enough control measures for the trucks, the traffic flow, and things of that nature. Next slide, please. The last thing I want to talk about, and it already was mentioned more than once, but taglines. I've seen multiple times where the tagline that was tied off to the object was not sufficient. It was not strong enough, or the knot that was tied onto it failed, or maybe both. So we need to make sure that we understand when you're like the jib section on this crane that he's tied off to, it may be a single section that's 200 feet long, or it may be multiple sections of 150 feet long. If that object can strike the crane that's hoisting it, that is a major deal, right? And everybody needs to understand we need multiple taglines on this object because you can't push a tagline. I know it seems so simple and fundamental, but once that piece is in the air and everybody's staring at each other because they have somewhat lost control, it gets out of hand. So we just need to make sure, one, the taglines are sufficient, and two, that we tie them off to something that's going to control the load. Because if the wind gusts, I've seen, and I'm sure Mike and Tom have seen this too, but people going water skiing across the job in their boots, right? Because the wind is pulling them and they cannot resist the tension that's in that. And we just need to make sure to tie it off to a column with a half hitch and let it run through, or a forklift or something of that nature. Just make sure that an individual is not just trying to hold the tagline by himself at the end of the day, because he will not be able to withstand that tension. The other thing is the fall zone. And to define a fall zone with an object like this is any foreseeable area where that load can fall, right? And that's a very large area. So going back to what Mike said and to what Tom said, we need to make sure that while this assembly or disassembly is going up, that, I mean, we have everybody out of that fall zone, because things can happen, right? I mean, we don't expect for anything, you know, to happen, and we inspect everything, but time has proven that the accidents happen. So just make sure that everybody is out from within that fall zone, and everybody has been communicated to have different control measures to gain access to their normal work site. So I guess that's about it. I know we wanted to leave a little bit of time for Q&A. So I guess as the questions come, we'll try to field them.
Yeah, so thanks. We had a couple of questions that were pre-submitted. So I will go over those first. And this one is probably going to be best for Dr. Bob and Hank. The question is, how effective are proximity alarms in preventing struck-by incidents with heavy equipment? So I know that our topic wasn't directly on that, but can you provide some insight?
I personally, are you there, guys? I personally have some experience with both devices, and they're only as good as how they're set up, for one, and they can be manipulated, and they can let you down. So I wouldn't think of any of those devices as a total fail-safe where you would run it as like an operator aid. That's a backup to your normal plan. And I've seen where they have let people down, and like I said, I've seen where they were not programmed correctly either. And it wasn't just for two cranes collision, it was for prevention of power lines on a site.
Yeah, I would agree with Eric on that. There's actually, you know, other things where, you know, with the cameras and things like that, where you start to get into a little bit of information overload for the operator, where he already has two screens that he's watching, and you just added another screen. And in some cases, like Derek was saying to you, you know, you got to get a little false sense of security there. And I really don't think there's enough data to prove that they really are an aid. That it's not just, you know, like something extra you want to throw on, that's fine. But I really don't see to where it's being proven to be an operational aid or anything like that.
This is Bob. Hank had to drop off, but in the description of our three cases, I can't see how a proximity alarm would have been a prevention tool.
Okay. All right, our next question is, what are some safe work practices for small lifts that do not require lift plans?
I'll throw some at this just real quick. I'm sure all of you guys have a lot to say, but I don't care if the lift is small or a maximum critical lift on the biggest crane. You got to have qualified people working around that crane, and I'm going to leave it at that. But the people working around the crane make or break that crane operation.
Yeah, I think I can echo Deke on that. The training is critical, and not just initial training, but that it's done on an ongoing basis. People are kept up to speed in terms of they maintain proficiency in what they do. There's a lot of it, the overwhelming majority, I mean by a landslide, of lifts that are made are done with what I characterize as craft rigging. Right? You know, this is, you're grabbing, you know, it's a Christmas tree for running steel up, or bundling pipe and that type of thing. And so it's a big part of it just goes to initial training, and then maintaining that type of training, and making sure from a proficiency standpoint that that's maintained.
Tom and I have both run pretty large tower cranes, and it's just amazing. Like, somebody will end up with that radio in their hand, and they'll say, "Hey, Mr. Operator, we're ready to make the lift." And I'll be like, "I never met you. I've never heard your voice before. What are we lifting?" I mean, we really need to make sure that, because I mean, we're really specializing on this presentation for tower cranes. So just please make sure that those individuals that end up with a radio, they're basically controlling the crane, right? I mean, the crane is working in the blind a lot of the time. And just make sure that that individual that ends up with that radio in their hand is qualified to have that radio in their hand. Because I'll share one experience with you. I'm lifting out of a blind spot with a bundle of number 8 rebars, right? And the guy says, okay, you got the load, go ahead and fly it. And I come up, and when I could finally see the load, I realized that the little J hook, it was the rod busters, right? The little J hook that they had on their sliding choker, their wire rope choker, was hooked into a number 9 wire that was just there to hold the bundle together. Well, by the time I realized what was going on, I was over top of the job, and it's raining rebars out of the sky. And thankfully, I got to witness something that didn't hurt anybody. But I mean, there's just individuals that should not be allowed to signal or rig on a job until they're qualified.
Yeah, I can't echo that enough. And, you know, coming from New York City, everybody thinks that we're over-regulated. But we actually had something happen last year that I thought was an enormous step in the right direction. There was an operator on a tower crane, and he was picking in the blind, and the guy who was giving him signals told him, all right, you're clear, take it away. It was a skip box with some lumber and garbage in it. And when he took it up, a piece of wood was sticking out of the side. It hit the edge of the beam, flew 30 stories off of a building, and landed in the middle of 11th Avenue in Manhattan. When the inspectors came out, the fine went to the signalman. It didn't go to the operator. And it was the only time I had ever heard of that happening. And they are starting to, and in the B30 standards, responsibilities for the signalman and for the riggers, I think was a great step forward to where everybody's got a little skin in the game now.
Those are great comments, and I think really solid advice. So I'll go on to our next pre-submitted question, which is, what are some common accidents with cranes? What should I be aware of when I'm working on a crane?
Well, I think you can start at the ground in terms of tipping and overturns, that you've got adequately prepared ground conditions, that you've got adequately sized matting or pads that are being positioned. They're able to withstand the reaction forces that come off the outriggers, or if it's a crawler crane, off at the tracks. Understanding the below the hook equipment and the rigging. How, you know, to Deke's point, you know, it's, somebody doesn't connect the rigging properly, it can be sized right, it's not connected properly, and you have you can have a serious accident as a result of that.
And going back to what Mike just said, that assist crane, and then even going back to what Tom said earlier, but when it's time to disassemble the crane, it's not, it could be a little bit different out there at the site. It's going to be drastically different, right? We just need to make sure that we can get the crane where it was supposed to be, because there is limited real estate left on those sites. And even when they're going up, there's going to be steel and rebar and forms all over the place. And we need to make sure that that assist crane can get where it's at, because there's always a basement, right? Somewhere nearby, there's something that you're going to be pushing those forces, like Mike just mentioned, and they may be able to accept them, and they may not be able to accept them. We need to get that crane in the spot where it was planned to be, and we know that ground is suitable for that crane, because those are very large cranes that are putting them up or taking them down. I mean, there's a lot of reaction force coming out of the cranes.
Yeah, well, and along those lines, a lot of times folks will go to sleep on the assist crane, and the change in conditions. We're in Chicago, so we run into a lot of the same situations and conditions that New York has. We've got a lot of old installations. You've got vaulted basements, vaulted sidewalks. So it's not necessarily just a direct load that's applied, but it's a surcharge. It's the lateral loads that are generated by the outriggers. And just to Deke's point, when the crane's erected, oftentimes the assist crane is going to set up inside the site, and you'll have a reasonable amount of real estate to deal with. When it's coming down, however, building is largely erected at that point, and now, you know, the assist crane's out in the street, you're in the public way, and you've got a whole set of different conditions in a far more constrained area to be able to work with. So there's, you know, again, it's a completely different planning scenario from the setup, from the initial installation to the disassembly.
And if somebody is going out as an operator, the one thing that you got to put in your head is that you're always going to get pushed. There's always going to be somebody looking to save a little time or cut a corner, save a little money. Whoever's on the job, it's a job of money. That's what construction is. Production equals money. And nobody's going to tell you, hey, take a break today. Everything's pretty good. So you can slow down a little. But you got to make sure that you always want to be productive, and you want to make sure that you're helping the contractor make money, because that's why you're there. But you also want to make sure that you're doing it in a safe way, because in all reality, the operator is basically the last line of defense sometimes between something really bad going wrong. So we always say that, you know, a miscalculation or poor planning on the contractor's end does not constitute an emergency to the operator. So just make sure you do things in a safe way, and make sure everybody goes home safe at night. That's the biggest thing in this business.
Tom, I got to add one last thing, and I know you're going to back me on this. The wind, when the crane is in operation, and whether it's this crane or not, but when the tower crane is in operation, please do not leave it up to the operator to make the call. Have a standard on your job, instead of having the operator say it's blowing this hard or doing the crane. A lot of times it can be functional up to 45 miles an hour. And there's nobody that is going to do lifting in that kind of wind. And just have a safety standard in place. So it's a cutoff, right? Like Tom just said, don't leave it up to the operator to make that call, because he has a completely different perspective in the air than what they do on the ground.
Yeah, and also what I mentioned about the weather, keeping track of the weather, that's really something that has to be done. And a lot of times it's taken for granted, and people kind of push it off. Yeah, it's all right. It's not too bad yet. You can't see the wind. So when you have something that can affect you that much and you can't actually see it coming, it can really hurt you. So just, like I said before, safety. Everything should be based on safety. Everybody wants to make money and everybody wants to do well. But you want everybody going home in a safe manner to their families at night.
Well, and to that point, part of the pre-plan, if you have to lay the boom down, when you're talking about the assist crane or if it's a crawler, know where you're going to be able to put it down. If you have a weather event that triggers and you've got to react quickly, you can have a mechanical failure on the crane and you need to boom this thing down. You need to know where you can safely bring it to the ground and be able to work on it or get it out of harm's way. So whether you're going to jackknife a luffer and that's going to be adequate, or if you got to lay all the way flat, make sure you've got the real estate lined out and know where the operator knows where he's got to go and others, so that they don't encroach on that area and now create a problem. You don't want to run looking for keys for vehicles to try and clear them out of the way.
Those are great comments. We have one question left, and this is more of a question that we can follow up on, but somebody asked if we can get the reference for the recent fatality Hank discussed, and we could follow up with Hank to see when that report's going to be available. But thank you guys all for attending today. We are at time. If you have any follow-up questions, feel free to reach out to the CPWR. We can definitely answer any of those questions for you. But thank you again for participating today.
Thank you.
Thank you.
Thanks, everyone. Great job.
Have a great day, everyone.